Well, I like to do math because I like to understand and to really take apart complicated questions and articulate what makes it work. But I didn't really choose mathematics for my studies. My degree is in physics. So I always was interested in understanding why the world is the way it is, why the sky is blue, and so I was physics attracted me for that reason. But then as I was studying physics, I saw there was a lot of mathematics that is needed to even formulate the physical questions. And I really like that. And I like to also construct new mathematics. With physics, you have the physical world and you try to understand it and you build a mathematical formalism. But I also like engineering questions where you use mathematics to construct new things. So that's what makes me an applied mathematician. Well, a shockwave, I don't know, but I do remember when I was little, and if I couldn't sleep, I would multiply numbers. I would multiply 2 times 2 gives 4 and so on. And I was fascinated by how quickly these became very, very, very large. And I would try to keep in my head numbers of 12 digits, of 13, 14. And it was amazing how large they get. I mean, so that was exponential growth. But I also remember I had dolls, and I liked sewing and knitting, and I was fascinated by the fact that you could take flat pieces of fabric and make curved surfaces out of them by sewing and putting seams and so on. So I thought that was very intriguing. And I built out of scrap, and it didn't last very long, but a little toy with which I could weave. I mean, so because I like the idea also that you could weave things and could make complicated wefts, and so I like doing things with my hands, but I like to build nice properties in them. So I think that was the beginning. Oh, well, there are a number of people. Actually, in my undergraduate years, in my second year, I had already discovered that I really liked mathematics and I was considering changing. And then we had a course of Fourier optics, where we learned that an optical system, a lens, in fact makes a physical Fourier transform. And I thought that was so cool. And so I stayed in physics. I've never regretted that, because although I don't do physics in research anymore, a lot of the physics I learned during my undergraduate and graduate studies has come in very useful. And I learned a lot of math on my own. And so having this unconventional path towards all these, towards this, has been a good thing for me, I think. And then who influenced me during my PhD? Actually, I was enormously influenced by Alex Grossman here at the Centre de Physique Théorique in Marseille. He really he shaped my taste. I mean, and he was a master in writing derivations which were one simple line after the other, and he would write then what seemed complete trivialities, and then you would end up with something, you would say, wow, how did he do that? I mean, as if he pulled a rabbit from his sleeve. I mean, he was really great at that. So I like to work with others. I like working with other people in science, in engineering, or even outside the sciences. I've started to work with art historians, for instance. I like hearing about what people do, about how things work in other fields. And often, I mean, I'm just curious, and I think it's fantastic. And occasionally, I hear something where I have the impression that my mathematical way of looking might help. And so I then probe a little deeper, and if the other scientists or engineers are open to it, we try to talk more about it. And then if a question gels out of that I feel I could contribute to, then I start thinking about it, we start meeting more, and so that's how it builds up. So over the years I've worked on a number of different projects in different directions. I have enjoyed them all. I like to extract the mathematical question. I work on the mathematics, but it's always stimulated by the application, and I try to remain relevant to the application. So I'm happiest when at the end or at intermediate stages I can feed back information to the application that is useful for the others. As a result, I haven't worked by becoming an absolute expert on a domain where I dig deep. There are a number of things I've become much more expert on than on others, but I've also liked variety and looking at different things. Yeah, well, I like coming here because actually I came here already long before wavelets, since I worked with Alex for the work that went into my thesis. But later I came back after my postdoc to work again with Alex, and then on the beginnings of wavelets. And so I met Jean-Morlet then, who was a very impressive man because he was very intuitive. And he also, the synergy between Alex Grossman and Jean-Morlet was fantastic, because Jean had insights but didn't articulate them always very well. But Alex listened to him and then articulated, and that's what gave rise to the whole development of wavelets. So I think it's really wonderful that you honored Jean-Morlet by having this chair here. Oh, that's like asking a mother what child she likes best. That's not a fair question. Well, usually I'm fullest of the things I've been doing most recently. So yes, those are the most in my head right now. But I think every project I've worked on is something that really has had my passion and my energy. And I have liked working with other people, with my students, with my mentors, with colleagues. I also like sometimes figuring things out on my own, but I like bringing them back. And so I like that give and take of research. And so that's the aspect, I think, of my work I have liked most. The way working with somebody and getting to really know them, and having this dialogue with them where they already understand you with half a word. And sometimes that doesn't quite work, and then you have to use all the words. But on the other hand, they also force you to really articulate what you mean, and you actually understand it better because you have to explain it rather than just being vague about it. So yes, I like that aspect of it. Every time I work on something, there are a whole lot of small Eureka moments. And of course, sometimes it all gels together. I tell my students that when they have this impression that they were working feverishly on something and then it gels and they see, oh wow, it works, that they should then sit back and enjoy it for half an hour. And then after that, they should check it, because a good part of the time it's wrong, but at least you've had that good moment. And then if it's still right after you've checked it all, you should enjoy it, the joy it gives, to the hilt, every second of it. Because a week later, you'll already be telling yourself that you should have done it much sooner, that it's so much easier than you thought, that, you already, the gloss will have gone off it. Because as you understand it better, it will seem more natural, and so you'll be kicking yourself for not having seen that much sooner. So the highs are great, but they're not so very long-lived. So you really have to enjoy them when they come. Well, that's again a very difficult question. I am who I am, and I certainly am a woman. There's no question about that. And I am married, I have children, I have enjoyed that part of my life, and I'm enjoying that part of my life enormously. I hope to be a grandmother before too long. It's not in the offing yet, but so on the other hand, I can see that it's a world in which there are fewer women than men. I mean, and I regret that, because I think the nature of research is such, we don't really know where ideas come from. But I know for myself that after I've locked myself up too much, it's good for me to go out, to go to talks, even not on my subject. Will it stimulate more ideas again? So it's good to be exposed to a range of things. And so I think it's also good for the research world to be a world where people from very many different backgrounds and different ways of reasoning meet and work together. And so I think the world of mathematics will be enriched by having a wider range of people participate. But I also think it is funner as a human pursuit if you have a wider range of people. Mathematics is a field that sometimes is known for having very absent-minded or very eccentric people in it. And part of that is because you can be good at mathematics without needing great social skills. I mean, it doesn't mean that having terrible social skills helps. On the contrary, it never helps in any pursuit in life. But at least it's possible to do it, while there are pursuits in life where it wouldn't be possible. And so mathematics is a very welcoming world in that sense. And it would be great to see that the world of mathematics to be more diverse, gender and ethnic-wise. But we're getting there, slowly, but we're getting there. Well, if you want to become a mathematician, you have to really like what you do. You have to really like mathematics and know that doing mathematical research will be a frustrating thing because it's hard. But if you're passionate about mathematics, then it's also great. My students sometimes ask me, should I take this course? Will that be useful for my thesis? And I always tell them you should learn all the mathematics you can, whether or not it's useful for your thesis. If you have the time for it and you have an appetite for it, you should learn it. Because I have not encountered a single piece of mathematics that is not useful. I mean, I'm here at a workshop, and there are some talks that are way far in different directions from my own, but I still pick up interesting things, even, and I note things that, oh, I should look into this. This might be useful, and so I also think that they should be open to connections outside of maybe the specialty they're going to look at. Right now it's an extremely interesting period in mathematics, because within mathematics there are a lot of different fields that are making connections with each other that it didn't seem to be connected, but these connections are being made. But there are also connections being made with fields outside mathematics. With physics is an example that has existed a long time, but there are more connections now that are made than before, but also with biology. I mean, biology, as it develops, is getting more and more not only quantitative, but it also needs the design of frameworks in which you have to develop new mathematics, new ways of looking at things. And so mathematics is everywhere. There's a saying, I think it's Mark Katz who talked about the unreasonable effectiveness of mathematics. And I don't quite buy that, because yes, mathematics is maybe you would say unreasonably effective at describing, at giving us frameworks for the world. But on the other hand, whenever you build a framework, you're doing mathematics. So in a sense, building those frameworks is called mathematics. Then saying mathematics is unreasonably effective, if mathematics is the name for the thing that you do when you want to try to describe it, it seems like a kind of vicious circle. So in a sense, I feel we have nothing but mathematics in order to really articulate descriptions, and but that's why it's fun and exciting. Oh, well, Cirm it's a great place. I mean, places where people come together from many different directions and talk to each other and interact, and without too many distractions. That's wonderful. And this is also in beautiful surroundings, so you can go out for a hike with others and discuss things and come back and be refreshed. Well, and I came here when I was very young. I mean, I've been coming to Cirm for, oh my, over 35 years now. Well, it wasn't Cirm even then. I mean, but I've been coming to Lumini for over 35 years. So it's when I came back now, I was thinking back about the earlier stages in my career at which I came here, and of course that was fun too.